Check, check. Yeah, get a little lower. Okay, we're live again. Excited about this one. A little nervous, but excited. It's been a long time coming. Yeah, gonna be diving into Rust, kind of just diving in pretty raw from zero here. I knew at some point, well, I've known for a while, for one, I wanted to learn Rust. And for two, I knew it was something that a lot of other people want to learn, a lot of pleb devs and just like other developers, but it's, despite what other people may tell you, I found it to be something that's like hard to start with, especially if you're a new programmer. So I've stuck with JavaScript, I've stuck with Python. It lets me do a lot of what I want to do as a developer, like build what I want to build, and I don't have to worry about a lot of the, constraints that actually exist in the world. But Rust is like the maturing of the pleb dev, I think. Or not just Rust, any low-level language, right? Where you're actually managing memory. Because that's going to be one of the big changes here for me or for anyone that's going from Python or JavaScript to something like Rust or C++ or Go. It's going to be memory management, and it's going to be strong typing. Those are going to be things that maybe you haven't dealt with or have only dealt with very little. So I guess those are the things I'm looking out for that are probably going to be more difficult or have a bit more of a learning curve for me. But either way, we're starting from like the first chapter today, so it should be a pretty soft introduction. And yeah, a lot of the concepts are just going to glaze over, I imagine, today. But yeah, I'm stoked to get into it. I'll probably give it like 3 or 4 more minutes before I dive into like the full start here. But I guess show what my environment is going to be for this. So that might be useful. Yeah, so I haven't really done this kind of streaming before. Like sometimes I do live coding or live hacks, I call them, where I'm like building something from scratch. I kind of don't know if it's going to work out, but it's at least within a language I know. It's at least an idea that I've thought about or done something close to before. And then I do workshops, which are like totally prepared. I know it's going to work out. But I haven't done anything like this before where I'm like trying to genuinely learn something myself live and also make it useful for others. So I thought about it and I was like, I think I'm gonna make like kind of a visual note system as I go through this, and this will be for me and maybe it'll help other people. But I found this cool open source app. It was called draw.io or drawio.com. Yeah, this one here. And it's open source. You can use it in the web or you can download it. And I downloaded it here. It's really orange. And this is what it looks like. And it's basically just like Lucidchart or just any kind of like workflowing app. But for me, I'm gonna be putting my notes here. So I'm gonna have like a walkthrough section here where this is gonna be the first session we're doing. So I'm gonna put kind of like what I'm going through, the steps, the things I'm learning. And then this left side, this is gonna be the most important to me. And this is gonna be like the concepts. Like I'm gonna try and break down all the different concepts from types to like cargo. This is something I know we're gonna deal with today. It's the package manager essentially for Rust. So I just want to kind of like condense, almost make a cheat sheet of my own of these concepts I'm learning. So yeah, we'll be giving this a try, and if my notes are good, I'll probably like publish them in a README as well. And yeah, what else? I made this repo. I'm gonna be just like pushing all my code into this, and we'll probably be dumping the notes in here as well. Also, I'm going to be using ChatGPT here, an important tool, and I already queued up prompt for us here, because a lot of what I'm going to be doing is like taking stuff from the book and having ChatGPT summarize it for me, or just asking it questions like, what does this mean? So I'm telling it, you're a Rust programming expert, You're going to help me, a beginner, develop my notes and answer some questions. You'll cut through all the abstract BS and buzzwords and help condense my notes and answer my questions in an actionable, clear, and concise manner. So a lot of what you can run into when doing something like this is, just end up in like the realm of all this lingo and forget what you're actually talking about and not making it actionable. And I want this to be actionable for myself mainly because I want to learn what I need to learn and then start building with Rust. I don't like reading books. I don't like spending like too much time in the learning zone. I want to get my hands dirty. And so we'll get to do that today. This will be the first part. You can find the Rust book here on this website right here. I'll post this to the README. I'm actually going to do this from VS Code because I have this here. Just so everyone can have this. But yeah, if you just like search Rust book, you'll find it. Okay. Cool. Oops. So I'm gonna close this. Okay. Let's get started here. So we are going to be going through, like it says, over here on the top left. It's kind of like the checkboxes of what I want to go through today. So it's going to be Hello World, Hello Cargo, and the Guessing Game Project. And that's kind of like basically the first two chapters, sort of. I guess this is the first chapter here. And these installation steps, I'm essentially going to be skipping these because I have everything installed. I also didn't want to go through that live because I don't really know what the hell is going to happen. So I've already got everything installed, but it's pretty straightforward to install. It does take some time. And alternatively, you can always like go to Replit here, especially if you're just like writing your first Hello World or something like that. And we can go search for templates. We can go find a Rust template and just create a REPL. Just like this, and we'll have a little Rust environment here, so that's really nice. I want to do things locally though, and I think it's good to learn to do things in your local environment and like set it up, and all of that spiel. But cool. I think I'm gonna get into this now. Should I read any of this? Any of the introduction? Is there a button to like? This is actually something I can just start with. Is well, screw this. Screw copying it. Can you give me a high level pitch on Rust and why I should use it? So I guess for me, despite what it says here, I know, and you probably know, and you've probably heard just from the Bitcoin space, some of the most cutting edge projects right now, some of the most important projects, they're being built with Rust. LDK and BDK are big ones. I'm trying to think what else is built on Rust. I know Mutiny Wallet is built on Rust. They're definitely a big inspiration for me. There's Nostr relays. Really, there's a lot of Bitcoin projects, a lot of very low-level projects. And so this is kind of the stuff that traditionally, for me as a pleb dev, I haven't been able to touch because this stuff isn't in JavaScript. This stuff isn't in Python. A lot of times in JavaScript and Python, you're dealing with an abstracted version of something. And these lower-level languages are the opportunity to, go down to the roots of what's happening. That's how I see it. And so Rust is a newer language. Let's see what it says here. Rust is it's a system programming language. It's supposed to be capable of doing what C and C++ can do. Gets you close to the hardware. It's good for things like operating systems, game engines. It has good safety, performance, concurrency. I forget what concurrency means. Concurrent support, its ownership model. Ensures thread safety. Okay, so this is like multi-threading, or this is like the idea that your CPU might be running like multiple processes at the same time, or multiple processes of like the same app, and that can go out of control. If you've ever done like threading in Python, you probably know what I'm talking about. Interoperability, so operates with like lots of different systems. Memory efficiency, tooling and community. Yeah, cool. So I guess that's a high level pitch. Just to save my prompt here, I'm just gonna like rewrite this message for each of my questions. But okay, whatever, bit of a high level pitch, seems cool. The downside of Rust that I've heard, and from my little bit of experience I've seen, is it can be difficult to write, it can be difficult to learn. A lot of the concepts might be foreign. If you've already been familiar with like a C++ or something like that, where you're dealing with memory management. So if you haven't dealt with that stuff before, I feel like it's almost an advantage, because you're not relearning anything. Like, we're going to be learning and thinking about memory management essentially from scratch. So that's always a great way to do things. Do it from zero. Okay, enough talking. Let's get into it. All right. So installation, not going to do that. I'm going to start right here with the hello world. I'll probably zoom in this a little bit. Looks good. So we've installed Rust. Now it's time to make a hello world program. It's normally how we start things. And it's going to tell me to create a project directory. So I already have that made. Let's see. Projects directory. Do this, and it's telling me to make a hello world directory as well. So I'll go ahead and do that. So I've got my full project directory here with like a repo, and I'm just going to make subfolders inside of it. So we'll call this hello. Okay, didn't tell me to do anything else yet. So made our folder. Next, make a new source file, call it main.rs. Rust files always end with .rs extension. If you're using more than one word for your file name, yeah, use underscores. This is also called snake case, I think. So good to know. But cool, so we're gonna make main.rs, and this is what we're gonna put in here. So far, it's a JavaScript or a Python dev. I'm not feeling too bad looking at this, but I know it'll grow from here. So we'll make main.rs right here. I'll put this in. And so how do we run it? So we save the file, go back to our terminal, and run the following command. So rustc main.rs and then /main. So rustc, if you went through the install steps, this is what you installed. I should have rustc here. Version. Okay, I do. What is rustc though? What is this we're invoking? I'm wondering. This is probably a pretty simple answer. It's the Rust compiler. It's a command line tool. Takes your Rust code and turns it into binary code that your computer can understand and execute. That's actually a good answer. And that's a good kind of like insight for us pleb devs to be thinking about what's happening here under the surface. Ooh, gross. That, yeah, like, you know, with Python, for example, you write Python code. Your Python code it's not being compiled, transpiled, I forgot, there's some difference there. But your Python code ends up running as C code. But here with Rust, our code gets compiled down to binary. So right down to the machine code, right down to the hardware. So that kind of tells us right off the bat that everything that we're touching, like we have full control, full influence over it, which is kind of fun, kind of dangerous. So okay, we're gonna use rustc to compile main.rs. So let's do it. I need to cd into hello world. I'll say rustc main.rs. And I can zoom into this window as well. Oops. That looks a little better. And then it's said to do dot slash and run main.rs as a executable, I guess. So let's see what happens. Permission denied. Oh no. What is this? This got created out of nowhere. Permission denied. Do I need to do sudo? Oops. Main.rs. What am I missing here? // main.exe. Oh, okay, I see. So we actually turned this into an executable, and I deleted it. So actually, I want to run this command again, and then I want to run. It's main.exe because we just turned it into an executable. That's what this is. Okay. // main.exe. Do I just do / main? Okay, there we go. Hello world. Interesting. Well, that worked. It does say to do main.exe, but that's fine. Because this actually isn't going to be the normal, or I guess our normal workflow for doing things. Cargo is going to replace this process. We'll see that in a few minutes though. I want to see what this looks like in my folder. I'm just kind of curious. Yeah, I see. So it's just a main, so it's an executable file. I'm realizing too, this is on Windows. So it would become an executable on Windows. So I'm an idiot. I should have copied this line. Well, cool. Let's go. We got hello world. So we know now that this is this is how you make a function. This looks very similar to JavaScript. We have this fn keyword. Seems like main is probably sort of like in Python. I'm kind of getting the impression that everything is going to fall into main, and we're normally going to have a top level main function that kind of runs all of our other sub functions. That seems apparent so far. And then we see some kind of method, some kind of function here. We don't know what this is yet, but it prints a line. I know it does that, but I don't know what this exclamation mark means yet. I'm sure we'll find out soon though, so cool. I wonder if there's anything else worth reading on here. Anatomy of a Rust program. Let's review it in detail. So this is a main function. It is always the first code that runs in every executable Rust program. That is good to know. So yeah, these are some good first notes to take. I'm gonna copy this. It's gonna be our first code. And then I'm gonna write this or copy this little tidbit about main. I think that'll be a good thing to put here. So we'll go to a walkthrough here. I'm just gonna do box. Ooh. This is gross. I need this to be a code snippet. Can I copy this as a code snippet? Like this. There we go. I think there's some weird alignment going on here. So far this isn't, I guess, the best for putting code snippets. Okay, that's amazing. Cool. Well, we'll just talk about function main, and I'm gonna write down this snippet here. So and I need to have this text be like way smaller. Cool. Here, the first line declares a function named main. If there were parameters, they would go inside the parentheses. Okay, this is all stuff I'm used to. We're wrapped in curly braces, the function body. Use an automatic formatter tool. Yeah, we'll probably get, I don't know if I have any extensions or any formatting right now for Rust. Doesn't look like it. It's suggesting I get it. Rust language support. I probably should. I'm gonna go ahead and get this. No, we'll do this another time. I don't want to break my environment already. But yeah, formatting, that's probably something we're gonna get into a little bit later when we write some more code. So this line does all the work. It prints text to the screen. First, Rust style is to indent with 4 spaces, not a tab. Interesting. Is this something... Oh, that is true. Seems like my code is automatically formatting that way. Well, not necessarily. I guess if I save it, it's not enforcing it. Print line calls a Rust macro. If it had called a function instead, it would be entered as print line without the exclamation mark. Okay. Cool. We just learned a new concept about macros. Well, we don't really know what it is, but we can set something aside for it. So I'm going to go over here. I can't zoom out. I think I need to restart this. I know I did save it. Well, maybe screw the visual notes for now. Let's see. Open existing diagram. Should be learning Rust live. Yep. Edit. Okay, here we go. That was annoying. Okay, so I want to find another list here. And so this is going to be our thing for macros. And right now we only know one thing about it. Macros are denoted by the exclamation mark. And exclamation mark. Cool. So we'll discuss Rust macros in more detail in chapter 19. Okay. For now, you just need to know that this means you're calling a macro instead of a normal function, and that macros don't always follow the same rules as functions. I'm going to mention that as well. So hello world string, this is a string, we know that. Fourth, we interline with the semicolon, which indicates this expression is over and the next one is ready to begin. Okay. I'm just gonna put little tidbits in here. Need semicolon. That's a good thing to know. That's something I'm not used to as a JavaScript dev. Okay, enough hello world in this one. Let's see if there's anything else worth reading here. So compiling and running are separate steps. So you've just run a newly created program. Let's examine each step in the process. Okay, this sounds useful. For running a Rust program, you must compile it using the Rust compiler by entering the rustc command and passing it the name of the source file like this. compiling and running are two separate steps, so that's a good thing to keep in mind here. Compiling, shells running are two separate steps. Passing the name of your source file. If you have a C or C++ background, you'll notice it's similar to GCC or Clang. I don't know what these are. Linux or Mac OS. Okay. So we kind of know, I mean, we kind of bumped up against this. Like, we know it's two steps, had to compile it. After I compiled it, there was an executable. It compiled into a program that I could just like execute, and I did that. So, and passing the name of your source file. I'm just gonna add to this. Afterwards, after it compiles successfully, we'll get an executable. All right. If you're used to a dynamic language such as Ruby, Python, or JavaScript, you might not be used to compiling and running a program as separate steps. It's an ahead of time compiled language. Means you can compile a program and give the executable to someone else, and they can run it without having to have Rust installed. That makes sense, right? We're compiling it down to machine code. So, you know, any machine should be able to run it. They can read that machine code. What's up? What's up, Linus? Welcome to the stream. Gotten through Hello World so far, and we've done a lot of thinking about what's happened beneath the surface here. But this is some good high level context for what's happening to our code. Okay, cool. We can move on to cargo. So this is going to be very similar. I already know that. Edit my notes here. So cargo is Rust's build system and package manager. Most Rustaceans, that's not smooth off the tongue, Rustaceans. I know that's what they like to call themselves, but I'll have to grow on it, or it'll have to grow on me. They use this tool. Cargo handles a lot of tasks for you, such as building your code, downloading the libraries your code depends on, and building those libraries. We call the libraries that your code needs dependencies. Okay, as a JS dev, I'm pretty familiar with that. But this is interesting though. We just ran code with Rust C, but this is telling us it's going to build our code as well, such as building your code. Yeah. So simplest Rust programs, like the one you've written so far, don't have any dependencies. If we had built the Hello World project with Cargo, it would only use the part of Cargo that handles building your code. As you write more complex Rust programs, you'll add dependencies. Okay, that's good to know. So cargo handles building your code, downloading libraries, and building the libraries. I'm gonna write that down in my notes here for cargo. So cargo handles building your code, downloading libraries, and building libraries. I assume it also helps you like manage dependency versions. Random question, but are you usually standing or sitting? All that looking downwards hurts even my neck. Yeah, man, normally I'm standing, but I have a higher desk setup normally, so I should raise this up though. I could like raise my laptop up like right here. Oh crap. That just break my stream. Let's see. I think my camera just broke down. One second, let me try and fix this. Ugh. Well, yeah, camera is dead. How many cameras do I have? Well, I'm trying to reset it. It's like picking it up, but it looks like I should know not to wiggle the cords anymore. I'm using my iPhone actually as a camera. OBS lets you do it, but it's kind of a strange, like, slightly sketchy program. Okay, we can keep going. Who needs a camera? Oh, that is good to know though. That's more sensitive than I thought it was. Okay, back to cargo. So cargo handles building your code, downloading your libraries, and building them. That seems like a good high level description. So because the vast majority of Rust projects use cargo, the rest of the book assumes that you're using cargo too. Okay. Installation, installed, cargo dash version. Yeah, so cargo should be installed for me, cargo dash version. Yeah, okay. Cool. Oh, don't feel bad. That was my fault. I have like 8 things plugged into my laptop, and I was like, oh, let's pick it up 2 feet in the air. It's a bad idea. Okay, cool. So we have cargo. Let's create a project with cargo. So it looks like, let's create a new project, cargo. Look how it differs from original Hello World. Then on any operating system, run the following. Cargo, new, hello cargo. So I think this will create a folder, so I'm not going to make a folder for it. Because we had our hello world here. So let's cd out of this. Let's try this, cargo new. Okay. Hello cargo. So we have a whole little project directory here now. Cargo.toml. So I guess this will be like our configuration file. So if you were, what would you say? JS dev, I guess, you would think of this being similar to your package.json. And then a main.rs. And it looks like our code's already in here. So let's see how we run it. cd into there, hello cargo. Okay. The first command creates a new directory in a project. Go to hello cargo directory and list the files. Yep. Generated cargo toml, source directory, main rs inside. It has also initialized a new Git repository along with a .gitignore file. I did not notice that. Git files won't be generated if you run cargo new within an existing Git repository. You can override this behavior with dash dash. Okay. That's fine. Cool, so cargo.toml. This is exactly what ours looks like. Tom's obvious minimal language. I never knew what toml stood for. That's interesting. Which is cargo's configuration format. First line package is a section. Yeah, I mean, this is kind of self-evident to me, I guess. This is like describing our project. We have a name, we have a version. What does edition mean, though? Name the version, and the edition of Rust to use. Okay, I see. So that's like using Python 3 or Python 2, I guess. Kind of a similar idea. Last line, dependencies, is the start of a section for you to list any of your project's dependencies. Dependencies are referred to as crates. Okay. A lot of information here. So I'm gonna start putting this back in my notes. So cargo handles building your code. Cargo new. Creates a new project. And new project in cargo.toml source directory, and it creates a new repository. If you don't specify otherwise. I'm usually not that good with notes, honestly, but I knew for this one I wanted to like take notes in kind of like a mind map sort of way where it'd be easy to come back to, because that's usually what I'm like. I can take notes, but I'm usually bad about going back to them and getting any value. So I'm hoping this system will work. I'm kind of like, I'm breaking things down into concepts on the left. I think this will be the most important part for me, is the concepts. It'll be almost like a cheat sheet, and then the walkthrough. And I guess this is going to be kind of the things that I'm learning as I'm going through this book, just as like I'm passing through, I guess. Yeah. And if they're any good, I'll probably share them at the end. So we create a TOML. Let's, and this creates next 3 lines of the configuration. Yeah, this is a good chunk right here to describe what we're making. So cargo.toml, and we're gonna have some stuff. I'm gonna have an example there, and then I'm gonna paste this here. We're gonna make it a lot smaller. Man, this pasting does not work very well in this program. If I drag this down. Okay, that works. Cool. Whoa. Okay, in our example TOML, what's this? Okay. Okay. So Cargo has generated a hello world program for you. We saw that. Expects your source files to live inside the source directory. I'm going to mention this. That's a good thing to remember. I'm going to mention this here. So cargo build is how we run it, it looks like. Let's try it. Oh, we need to be inside of our hello cargo directory. Okay, looks like it compiled. So, a few interesting things I'm noticing here. Let's see what it says about this. Yeah, thanks for dropping in. Yeah, I hope I enjoy Rust too. We'll see. I'm barely getting started now. Okay, so we built it. This command creates an executable file, target at target, rather than in your current directory. So because the default build is a debug build, Cargo puts the binary in a directory named debug. You can run the executable directory at this command. Okay, I see. So it's still an executable that you just invoke. That's good to know. So I'm going to make a new section here for cargo build. How do we add a Oh, okay, there we go. So cargo build. This formatting is terrible. Yeah, can I paste without formatting? Should be. Control Shift V. Nope. Clear formatting. Oh, it doesn't do anything. I'm gonna ask. I should have ChatGPT summarizing this anyway. Okay, so we did cargo build. Let's try cargo run now. So we just built a project, but we can also use cargo run to compile the code and then run the resultant executable all in one command. That's pretty good. So I guess kind of the cargo build builds your your debug. You can send to someone else, but cargo run will just build it and run it in one. So there we go. Hello world. All right. That looks pretty good. So let's see how it looks if I copy this over. It should be better. Cool, that is better. Nice, okay. Let's see, cargo also provides a command called cargo check. This checks to see if your code compiles. Okay, that's good to know. Additionally, cargo check sees if code compiles, doesn't run it. Okay, new project's ready for release. Cargo build released. Compile it with optimizations. Cargo's a convention. Over just using Rust C build primitives. Yeah. Okay. So I mean, yeah, we're gonna be using cargo like all the time here. This is a good tidbit though. This is a good tidbit. Okay, onward. You're off to a great start on your Rust journey. Learn how to install. Day 2 new reverse version. Open locally, run a few hello worlds, set up cargo. Okay. Alright, cool enough. That wasn't super fun, but we got some good high level concepts down, at least. Feeling pretty comfortable with what I've been exposed to so far. So that's good. Now we're gonna go on to the guessing game project. So I'm gonna take a small 2-minute break for this and see if I can fix my camera potentially. So I'll be right back. Okay, let's get back into it. I'm gonna try one thing real quick though. Okay, I can't fix it. I tried. Okay, let's get into it. Guessing game, here we go. So, likely, this is a whole chapter in itself. And this is a lot of explanation. So I might not get through the full thing, but hopefully we'll at least get to a place where we're accepting input and getting exposed to a bit more what the language can do. So we have our hello cargo. Let's get out of here. And it looks like we're going to be making a new one called Guessing Game. So this chapter introduces you to a few common Rust concepts by showing you how to use them in a real program. Learn about let, match, methods, associated functions, external crates, and more. Those are a lot of concepts. Let's get started. Okay, got a guessing game here. Okay, we know what cargo new does. We have a cargo toml, we know about that. Yep, we know this. Let's compile this hello world. I guess we can do that. Cargo run. Oops, I need to go to CD guessing game, then cargo run. Okay. So let's actually get started. First part of the guessing game, we'll ask user for input, process that input, and check that the input is in the expected form. Start will allow the player to input a guess. Okay. Let's copy this. A few things I'm already noticing about this. Looks like we're using some kind of library here. STD, that's probably standard. So we're printing a line, guess a number, please input your guess. It looks like we're setting aside some kind of variable here, string. And then, not exactly sure. Looks like we're reading the line from a standard input, and then we're printing it. Let's see. Let's go over it line by line. Okay, so this is the standard input library. Input output library. So I guess standard is library and IO input output is like the sub package of it or something. Program. So to bring the standard library into scope, you need to use the use command. Okay, that's cool. Don't need all the abstractions. This seems like import. So we have a main function. We're printing lines with our macros. We don't know what a macro is, but we know it can print a line, so we're doing that. Storing values to variables. Okay, so here's something new. So next we'll create a variable to store the user input like this. Let mute guess equals string new. So let, it's kind of like JavaScript. We can let name something and then assign it a value. This line creates a new variable named apples and binds it to the value 5. In Rust, variables are immutable by default, meaning once they've been given a value, they won't change. So this seems very similar to let and const in JavaScript, where we can say let apples, but that'll be a constant, or we can say let mute bananas, and that's something we can change. So that seems pretty simple. So, cool. Have ChatGPT kind of summarize this for me. This will be in our guessing game flow. Yeah, we'll make a new thing called variables here. this extra big. Oops. Copy this. Let's see what that summary is. Cannot be changed, mute, yeah, okay. Cool, so mutability. This is something I've also, like, I've heard of before. Kind of makes sense, because we are assigning memory directly here. So we need to know if that memory is going to change or not. Introduce a mutable variable named guess. Equal sign tells Rust we want to bind something to the variable now. Okay. Interesting. That seemed like a confusing way of saying something simple. So I'm going to say code is here, and then code is here. So it appears this appears to be some kind of function. I don't really get this yet. So, or I get the mutability. String is a type, and I don't know what this double semicolon means. So string new declares equal sign binds value. String new is a function that returns a new instance of a string. Okay. So I guess, okay, this is like a function. Seemingly I could like pass like some text into here. So that kind of makes sense. String is a standard library type. Represented by growing UTF-8 encoded text. The variable guess is thus initialized as an empty mutable string. Okay. I guess it's just syntax to get used to, this double colon. Cool. So that makes sense now. Yeah, this will be good to put. Over here. Let's make all of this way smaller. Okay. The colon syntax in the new line indicates that new is an associated function of the string type. An associated function is a function that's implemented on a type, in this case string. Okay. Associated functions, huh? I'm gonna ask summarize associated functions. essentially functions that are associated with a type rather than an instance of a type. Java, C++. That is, they don't work on an instance of a structure. Doesn't make sense to me. I don't have this context, ChatGPT. Don't have a self parameter. Can summarize associated functions such as the, I'm gonna find the example from here. String new. Is an associated function. It's associated with the string type and is used to create a new instance of a string. Within an impl block, we don't know what this is yet, but they do not take self as a parameter, so they don't operate on an instance. They can directly access instance data like an instance method could. We'll keep this for now. This still doesn't fully make sense to me because I don't know what impls are or like some of these other concepts it's talking about, but that's fine. We'll just set this aside. Make this a lot bigger. Come on. Okay. So we know that this means associated function at least, so I can put a name to it. Though I don't fully know what that means yet. Okay, so receiving user input. Recall that we included the input-output functionality from standard library. Now we'll call it from the IO module, which will allow us to handle user input. So once again, it looks like from IO, we have a quote-unquote associated function. This kind of just seems like, so far, like a function in a library that I can use to create new data. I don't know. But either way, we're using this associated function, standard in, from IO. So we can dot read a line. I guess we're assigning it to guess. So let's have ChatGPT summarize all of this. Can you summarize this? That works. Forgot it was movie night here at Pleb Lab. I hear explosions in the background. I'm missing out. Okay. And Rust allows us to incorporate input-output functionality. Give us the ability to handle user input by returning an instance of standard. Yeah, see, like some of this language here, like returning an instance of, like this. I don't have a mental model for what that really means. So it's kind of like useless to me. It gives us the ability to handle user input by returning an instance of what they input, a type that symbolizes a link to the terminal standard input. It's kind of what it seems like. Then we use the read line and mute guess method. Reads the inputs from the user and appends it to the string guess. And we pass an argument and mute guess, which means that we are passing a mutable reference to the string guess. The mute keyword, yeah, I know that. A reference in Rust is a way to let different parts of the code access a single piece of data without duplicating it in memory. That's interesting. That'll come in handy. A reference. Yeah, it seems important. Create a new concept for this. That. Reference, just insular. Okay. Is that all of our code here, basically? It looks like it. Let me save this. So. Printing lines, assigning our variable, reading from standard input. Kind of took a lot of consideration to get our heads wrapped around this, but I think I understand this now. So we're setting aside mutable, which means a data that can change, a mutable variable called guess. It's a new string, but this is coming from like the type of string. We have an associated function called new. We could pass something into here, but we're not. It's just empty. But we're still setting aside the memory, right? And then we grab the standard in function or associated function from the IO library, which is input output, which comes from the standard library, or I guess the IO package that comes from the standard library. So we grab that thing. We're reading the line from input, assigning it to the mutable variable guess. We're passing by reference, I guess you might say. At least we're making a reference variable, so we're able to, why are we referencing this again? This gives you a way to let multiple parts of your code access one piece of data without needing to copy that data into memory multiple times. Okay, I don't really know why we need to use this reference yet, but that is what it is. Dot expect, I guess this is like our dot catch. So we're still working on this line of code. We're now discussing a third line of text. This method. We could have written the code as is. However, one long line is difficult to read, so it's best to divide it. Okay, yeah, I know that. Ooh, there's a lot here. Result types. Okay. Let's have ChatGPT summarize this. Summarize this. I'm gonna say in succinct points. Okay. So read line takes a user's input and puts it into a string, but it also returns a result value. Result is an enumeration, also known as an enum, that represents one of multiple possible states. Okay, and error. Okay, so this seems a lot like dot then dot catch, sort of, where like you're getting some kind of a response, but that response will it'll either fire off in one function or fire off in the other function. Okay indicates the operation is successful. Error means the operation failed. Result values have methods on them. One of them is expect. If expect is called on an error value, it causes the program to crash and displays a message passed to expect. Okay, cool. So this is like a dot catch in JavaScript. Yo, what's up? Welcome back. Sorry, you can't sleep. And then we're printing you guessed guess, and I can tell here we're, passing in this variable. Looks like we only need these what do you call them, curly brackets to put, what do you call that, string interpolation, to put it inside a string, put our variable inside a string. Okay, let's finally run this damn piece of code. I'm tired of talking about it. Let's see if it works. So I should be able to do cargo run. It's actually the last command I ran, just cargo run. So guess the number, please input your guess. So let's put in 1. You guessed 1. Okay, cool. So this is all working so far. I wonder if I can get it to fail. What if I put in K? You guessed K. Okay. It doesn't care. What if I put nothing? You guessed nothing. Okay. So I'm still not getting an error to fire here. How can I get this error to fire? Maybe if I put a bunch of stuff? No, it doesn't care. It just says, it's just casting whatever I'm giving it, it's just casting it into a new string. Yeah, so I don't even know how to break it. So printing values in the print line, placeholders. Try Control D maybe? Control plus D. What does that do? It's gonna blow up my computer. Just kidding. I am on a Mac. Yeah. That sends into file. Okay. Yeah, this is just happy to cast nothing. Well, I mean, yeah, it's casting the string. It's happy to kind of just take whatever and still print out guess either way. Yeah, I wonder what would cause this to fail. Actually, let's ask ChatGPT. How do I get .expect to fire here? I should say as a user. As a user. Such as interrupting the program stamp. Dang, okay, well, this is a pretty hardened program already. It's kind of funny. I'm not going to go through that step, but I was just curious. Cool. So this is what would put us moving on to the rest of our program, but I think this is a good place to stop because I'm already like, looks like we need to get ignored here. I feel like I'm already behind on these notes because this note-taking system has been way too fucking messy and having a lot of formatting problems. So I want to take everything that I've kind of like barely summarized here and I want to remake these notes like before next time. So I think I'm gonna stop right now before I have too much more to go over. But this has been pretty cool so far. I mean, we did not finish the guessing game here. Didn't realize how long it was, but got a good start here. Got some of the high level concepts in play. Learned a little bit of syntax, got a few concepts down, a few names to get familiar with. Macros, associated functions, references, variables, we obviously know what that is. There's a lot of other little keywords in here. I should keep, is there like, I'm sure there's a Rust, let's see, Rust cheat sheet. What does this look like? Yeah, this thing is so big. This is cool though, this will probably be something I'm gonna return to. And I should probably, maybe I should just use this as my notes rather than make my own. Because if we search, like if I search macro, so macros and attributes. See, but this is the kind of, I guess I have ChatGPT for this, but another resources checkout is Rustlings. It's an interactive way to learn fix Rust errors. That's cool. Rustlings. Someone gave me a book suggestion earlier. Rust by example. That's cool. Exercises topic. Generics functions. Okay, that's cool. That's cool. So if I go to like macros. Oh, nice. Yeah, I kind of like this a lot better than a cheat sheet. Like this is a better description. Powerful, but also difficult to wrap your head around. That's good. That's a good primer to have. Fully featured macros. Instead, we'll show you how to use and create them. Project. Information. Macros. Yeah, this links back to the book. So we would be seemingly going through the Rust book. We'd be using macros for 19 chapters before we talk anything about it. But it looks like we're only using print line, so yeah, I don't know. A lot of keywords here, but yeah, cool. I'm gonna get my notes in order for next time, but I would say this is a good intro for my first time. Nice. Yeah, I'm definitely gonna check out Rustlings. Maybe we can do like a few Rustling exercises like each time to warm up or something. But yeah, cool. This was a fun kind of experimental stream. I will keep coming back and doing this learning Rust live, probably every either Wednesday or Thursday night. And hopefully, yeah, I mean, start getting to a place where I can build fully in Rust. Can do them alongside with the book. Okay, that's good to know. Yeah, I might consider that for like a different structure, because I kind of just went into this raw and was like, what would be a good structure to do? I figured walking through the book, but this is not very interactive. I mean, there's obviously a lot of dense information to learn, but I would want to have more interactions, I guess, per hour, whatever. But cool. Yeah, thanks for the suggestions and thanks for hopping in. Really appreciate it. But I'm gonna call it here for the night. Definitely keep an eye out for more streams. I might do a workshop this weekend, maybe a Keysend workshop. I've been working on it. Might not be ready by then, but I've been playing around with some Keysends with Lightning. So maybe we'll do that this weekend. We'll see. But either way, until next time, thank you again for tuning in, and I'll see you all on the flip side.